Hello and welcome to the Nova Show. I'm your host, Chris Nova. Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. How's everybody doing? Welcome to the show. Welcome in, everybody. It's good to see you. I held the intro for as long as I possibly could. I just like stood here as long as I could. How's it going? Welcome to the show, everybody. Welcome in. Welcome back. My cameras and everything's they're all over the place, so we'll dial it in. We gotta like re-get everything nice and set back up so I can get back into it again. How's everybody doing? It's good to see you. It's good to see everyone. I have been on a long journey. I feel like Gandalf the Grey turning into Gandalf the White, coming back after a long journey. I've come to some really powerful conclusions. But I think the two words that come to mind, ego death. Ego death. Who knows what ego death is? Who's familiar with this term? It's a well-known term. Who knows this term? Been really important to me recently. I want to kill my ego. Did I slip into the reins of space and time into the desert? Sounds like fun. Yeah, so who knows what the Black Rock Desert is? Have y'all heard of this? The Black Rock Desert is a very special place. It's a sacred place. It's one of the most beautiful parts of our country. It's on the Pyramid Lake Indian Reservation. Gorgeous, wonderful piece of nature. Desolate. And there's a few sand flats out there. Very large areas of sand. So I spent a couple of days out there. Alone. Not with anybody. All by my lonesome. Just me. I parked my car on the edge and I ran to the middle. Anyway. How's it going, everyone? Let's see who we have here. Let's say hi to people. Let's see what we have to say. So, B. Santana Scalper's here. Hey, how's it going? Hassan Ahmad is here. Hello. Issy Hogo says hi. Faf and a Boot, you know I love you, Faf. I love Faf and a Boot the most. It's good to see you. Simula Crumb says, hey Nova, good to see you. Zur is here. Gaming Means No says, great surprise to see a Nova show tonight. Yeah, you never know what you're gonna get with old Nova pants. That's what my partner Q always says. Gannett's here. Hey Gannett, how's it going? Whiskey Pewters is also here. Hey, how's it going? Felipe Codes is here. Holly Computer says, good to see you. Gaming Means No asks if I went into the depths of GitHub. I mean, yes, I've definitely been in the depths of GitHub. No question there. I think the question is that the only place I've been? And the answer is no. Pyramid Lake in Wyoming. No, not Pyramid Lake in Wyoming. Close. Pyramid Lake in northern Nevada. Northwestern Nevada. One of my favorite parts of the country. Heyo says Maddock. Grace Floofs Minch says hello, good to see you again. Thank you. Gaming Means No says, isn't that an LSD thing? I mean, so it's a psychology thing. So it's well known in psychology in general. And I think, you know, it's one of the things that psychedelics use as a term to describe like the euphoric effects that some psychedelics cause. However, you can have a conversation about ego death without necessarily having a conversation about psychedelics. For example, giving up a sense of self is very common in some of the more aggressive communist cultures. One can make the argument ego death is naturally a part of that. That might be a bit extreme, but I think you get the idea I'm trying to illustrate here. Is it Nevada or Nevada? I think they're all pronounced wrong, to be honest. Baff in a Boot says, I love you too, Nova. You're a wonderful and dear Linux hacker friend. We are going to hack some Linux stuff today. That's one of the things I want to get into. I want to look at TCP hijacking. I have an idea. We're going to see if it works. It's probably going to involve me writing C and getting very mad at my kernel, which it's been a couple of months since we've done that. So it'll probably be good to dust off the old 1.2 over here. Yannervite says, a couple times in the past year, I've wandered too far into the forest and cried for an hour, surrounded by the chopping sound of deer nearby. Similar effects. Yeah, I think so. I think when I think of ego death, I think of not necessarily like ego, like the Beach Boys ego, but like the part of the psyche that most psychologists would refer to, as opposed to the id or the super id or any of those other abstract parts of yourself. Effectively, I look at it like killing your sense of self to some extent. Particularly with the internet. I think the internet has a way of making people unusually selfish. Not inferior if you ask folks who live in Missouri. It's Nevada. Yeah, I hear that. Missouri. Anyway, let's talk about... Well, we can talk about a few things. We have a couple of things we need to talk about. Let's jump into it. Let's get on the screen the things we can talk about. Number one, I think the reason you're all here. Show of hands, who's here for TCP hijacking and who's just here just to see what the fuck I do? Let's be real. How many people are here for number one, and how many people are here for how do I do mine? There it is. And then there's also 3, and then there's also 4. What is 4? What else was I gonna look? I think that's all I had for 4. I think that's it for right now. Oh, I was gonna write a blog. Okay. So here's where we are. So here are the 4 things we can possibly jump into tonight, or I guess number 5 could just be full chaos mode. And just you know, go try to break something. Okay, so we could do a lot. Looks like a lot of people are here for number 2. Oh yeah, it's good to see you again. Hey Saltium, how's it going? Oh, we have somebody here for number 1 for TCP hijacking. The actual reason I wanted to stream. I have a theory. We're gonna maybe look at a TCP packet here in a second. Faff in a Boot says we're here for Nova. Awesome. So I guess as part of number 2, 6 is cake really a lie? So we could say 6 cake and climbing pictures. Although this would break my ego death. So these are kind of the topics I had in mind. I think this was the one that I want to research moving forward. So maybe I'll write a Rust crate for this one. I don't know yet. I have a couple of Rust crates I have in mind. This is one of them. This one could just be me ranting and answering questions. This is an interesting one. Number 3 is interesting. The reason number 3 is interesting is because my whole community is effectively now gone. Well, it is and it isn't. It's grown, it's shifted, it's changed, it's evolved. It used to be a Pikachu and now it's a fucking Charizard. My community used to be a little Discord and my little Twitch channel with my little Mastodon server, and well, it's been a year and that year flew the fuck by, and it's no longer those things. So at some point, as I start streaming more, we need to figure out what we want to do with our little Twitch group here again. I don't ever want to stop streaming on Twitch. One of the things I said when I started streaming on Twitch was when I said, this is my show, it's my fucking show, and it's always going to be my fucking show, and I made that distinction. And I think after some of you have watched Nivenly come to life and watched Hackaderm, rise to where it is today, I think you now maybe have a more deeper understanding of what I mean when I say it's my fucking show. I will claw my way onto this Twitch channel for life and death, and I will not let anybody take it away from me for any reason. So Gaming Means No says the Discord is very quiet, and I agree. So this is one of the things, was I think my Twitch stream was a big part of it originally, and I guess on one hand, if we separate me, the Twitch Chris Nova, away from the Discord, I suspect it will remain quiet, which I don't know if that's a good thing or the bad thing. I think the number two is if we keep it where it is, we continue to couple my Twitch presence to the Nivenly Foundation, which isn't necessarily the worst thing in the world. Izzy Hogo says, "Hi Chris, I'm a self-taught dev and am struggling to find a job right now. I have 2 full stack projects. Do you have any suggestions on how to break into an industry?" That is a good question. I did write kind of a small book on it. It's a really shitty book, but there is some prior art there. The Discord would be a good place to go. We have a channel there that you can leverage. It's called Hacking Capitalism, and there's the one for career guidance as well. I would encourage you to join the Discord. See, this goes back to the community point, which is I can't even answer these questions anymore. Everything's broken. Circular dependencies. Anyway, I'm probably not going to get into it right now. Maybe the link doesn't work for me. Let's get the link fixed. Which link are you clicking? Oh yeah, the website's down for Hacking Capitalism right now. That is well known. I can turn it back on if we want. But that is unfortunately offline for the moment, and I'd like to keep it offline if that's okay. Yeah, I just have a lot of cleanup work to do. This goes back into this. What the fuck am I doing with my life? For right now, you want to break into an industry, find yourself a good crew. That's the advice I call out in the book, and I'll say that here as well. And you can use our Discord as a crew for right now. Love to welcome you there. Go ahead and join the Nivenly Foundation Discord. And there you go. There's my terminal. Okay, so let's take a vote. Let's do a quick show of hands. Who wants to get into TCP hijacking, and who wants to do community work and get the Discord and everything dialed up so that people have a place to hang out again? Show of hands, who wants number 1 and who wants number 3? And then I guess number 4 is a natural follow-up to number 1. 8 Cesar says TCP. Gannett says an octet. Hassan Ahmad says number 1. Do what I feel like. 1. We're getting a lot of 1s. Okay, so the next question, we're gonna do TCP hijacking. Rust, Go, or C? We're gonna do TCP hijacking. I guess Rust. Guess we want to do things in Rust. What was 3? Do what you want. You can do what you want when you want. Thank you for the follow. So let's go to my GitHub. And let's go to github.com/chrisnova. And we're going to create a new repository. I like to say it that way. We're going to create a new repo. And it is going to be... Don't I have a Rust template I can use? Yeah, I have a Rust template I can use. What language are you most cozy with? I haven't written code in like a month or 2. So I guess they're all equally dusty right now. So it really doesn't matter to me, honestly. I think there's pros and cons to all of them. They're all gonna be slow in one way or the other. Go's gonna be slow with eBPF, trying to figure out how to do all that weird fucking Go compiler crap. Rust is gonna be slow. because it's going to take me forever to fucking figure out how to do stuff in Rust. And C is going to be slow because, well, it's C. Rust will probably be the fastest of any of them, if I had to guess. At the net, at the end of the day, Rust will probably be the fastest. Let's go with Rust. We haven't written Rust in a long time. I also haven't written Go in a long time. Well, we don't really know how we're gonna hijack these connections either. So let's just make a repo and we'll figure it out. Okay, this is gonna be Chris Nova. What do we want to call it? TCP Jack? TCP Jill? Should we call it Jill? TCP Jack and Jill? It's gonna be TCP hijacking. So the whole thing that we want to do is we want to be able to basically instrument an existing TCP connection. This is going to be interesting. Who are you? What did you do with Chris Nova? The Chris Nova I'm used to doesn't move slow. The road TCP Jack. Translation, good to see you. It's good to see you too. Welcome to the show. Welcome in. We could call it TCP Jack. We could call it Flapjacks. Hi Chris, welcome back. Hope you had a good vacation. Hey Vancouver, what's up? I did all the things. I went to the desert. I got dehydrated. I ran. When I thought I couldn't run anymore, I ran anymore. Get this. You want to hear something, some metrics about my vacation? I have data. I have metrics. You want to hear some metrics? So I got back from my vacation. I've been running. I did a lot of rock climbing. I did a lot of mountain climbing. And I got back. I had a doctor's appointment 2 days after I came back from Yosemite Valley. And I went to the doctor and they had to take my pulse. Who wants to guess what my resting pulse was? My beats per minute in my heart. Bear in mind, I used to have heart problems too, which is why I got into all this crazy exercise stuff in the first place. I used to have really bad heart problems. Not anymore. My heart's strong now. Resting heart rate. We have one vote for 78. We have another vote for 65. My resting pulse when I got back from my vacation was 60. 60. I got a screenshot of the thing too on my phone. I was happy. For somebody who used to have a bad heart, that makes me happy. So anyway, what do we think? TCP Jack? I kind of hate the name. TCP Trace? TCPI? TCP Inst? How about we'll go with TC Pinst? And call it TC Pinst? TCP? Cool, we'll make it public. And that looks good to me. What do y'all think? Create repo. Cool. Here you go. Good game on better health. I had a triple bypass last fall and I've been training to get back on track. Yeah, you know how it goes. Very nice. Mine is like 51. Nice. Vancouver, are you a runner? Is that your thing? Do you do a lot of cardio? Is that your thing? I don't meet many people who have a lower resting heart rate than I do, but they're usually either ultra runners or they do some sort of cardio. They're bike riders, or they're huge, hikers, people doing the PCT, stuff like that. So, I mean, they're in the top 1% of athletes for sure. Vancouver, if yours is 51. I ran 8 kilometers today. Yeah, you're a runner. See? There you go. Okay, so we have TCP Inst. We're gonna go ahead and clone it locally using my SSH. And then we'll open it up here in my IDE source. TCP Inst. Okay. And this is a cargo project. And we'll zoom in so folks can see. And there we go. And this is my Rust template. Cool. So what I want to do, let's get the README cleaned up. TCP instrumentation. Go. Nova, I DM'd you 2 questions on Discord. Not sure if you want to address them on the stream or not. I didn't want to ask in chat. Thank you for calling it out. Let me check and see. Opening Discord now. Here, I can check on my phone. Okay, cool. Yeah, you can ask both of those in chat if you want, Faf, but I'm gonna not answer them right now. Not that there's anything wrong with them. It's just off topic as well. But those are safe to bring up. I don't mind talking about either of them. Okay, yesterday was the first time in a while I had to walk a bit of the way back. I think the combination. No worries, I'll ask as we go. Awesome, awesome. Okay, so we're gonna look at TCP instrumentation. So, I have a theory. And I want to talk about our theory, and I want to clean up some of our code before we get super started. Oh, we're getting raided by Soy Pete. So let's do logger. Let's go into TCP inst and let's see if we can't make. We have a new and potentially unknown viewers in the chat. Thank you, Soy Pete, for the raid. How was your stream? Welcome to the show. How's everybody doing? What were you streaming about, Soy Pete? And DYB Star Player says hi. Hello, welcome to the show. Welcome in. We're happy to see you. Glad you're back, says Blastwave. Good to see you, Blastwave. Feels good to be back as well. So, we'll get this cleaned up as we go. So who wants to talk about my theory? I want this IRC. Oh my god, that shows you where my brain is at. That's what we should fucking spin up, y'all. Fuck Mastodon. We should spin up an IRC server. Fuck that. IRC. I would 100% hang out on IRC again. I am absolutely not even fucking kidding. What about if we did an invite-only IRC server? Like, and we like handed out like a fucking MTLS client cert, and we would sign your cert every 6 months or something if you were like part of the crew. I still hang on IRC. Ever since Freenode went down from all the drama, I just gave up on it. I would be back if I could. I run a home matrix home server that connects to IRC. See, this is another thing I would want to do, is set up a matrix server. Anyway, we're not talking about that today. What we're talking about are TCP packets. So let's dig into this. This is what I want to talk about here. Okay. So let's talk about TCP packets. Yeah, dude was about to say, hope it's been decent for you, but sounds like you're pretty close, eh? Blah. So I feel obliged to stay on because I wrote my own client. That's super funny. Oh my god, that's so dope, says Big Papa From. Cool. So, here's a TCP packet. For the most part, excuse me. So, a lot of this we can't really do anything with. We can't touch this. We cannot touch this. We cannot touch this. We know we cannot touch this. This data offset. So basically this section of data here is where I think there's some room, there's some wiggle room. I think we can find some bytes in here that we might be able to do some stuff with. These reserved bytes have been on my mind for a very, very fucking long time. Number one, because they've been reserved and nobody's ever used them. Number two, because they've been reserved and nobody's ever used them. Well, I think it might be time to start using these bytes. I don't know about y'all, but I'm definitely interested. I think I want to say there's 4 bytes here. I want to say it might be 8 bytes. Here we go. Let's see. Assigned to a particular socket are reserved 6 bits. Oof. Okay, so this breaks it down. So here we go. So reserved is 6 bits, reserved for future use. It is the future. It is the future. So the control bits from left to right, the urgent pointer, the acknowledgement bit. So it's 1 byte. It's 1.5 bytes. It's 1 byte and a nibble. Y'all know what a nibble is? And then we have the window is 16 bits, so that's 4 bytes. The future is now. It's the number of data octets beginning with the 1 indicated in the ACK field with the sender of the segment is willing to accept. What are we doing with future bits? It's not very much bits. The checksum we can't touch. We've already exacerbated all of the checksum research I'm willing to do for this decade of my life. I'm not doing any more research there by myself. Maybe if I had a team to help out, but not anymore. The checksum also covers the 96-bit pseudo header conceptually. So this checksum can cover the pseudo header. So we're talking about TCP encapsulation. Almost. It's not really full-fledged TCP encapsulation. But I do think, let's look at an Ethernet frame. Ethernet RFC frame. Let's see if we can't find you. Where are you at? I thought there was an Ethernet diagram. Oof. And IP datagrams. There's an RFC 1791. This is TCP UDP. Here we go. The internet header format. This is an IP packet. Flashbang, LOL. Okay. So this is different. So this is source address and destination address. So this is an IP packet. So here we have the header checksum. Now, is there any wiggle room in here? So here we have the length. Time to live. So there's this padding here at the end of the options, but this isn't very much. So each one of these is basically a byte. Or sorry, that's a byte there. That's actually, it's a byte and a half. It's 6 bits? I think that's a byte. Anyway, I digress. I don't know what those 1, 2, 0, 1, 2, 3s are across the top. I guess it's just for counting purposes. The offset. So I'm not seeing anything in here we can possibly use. Bit position. It's just base 10 counting is what it is. Do not be confused. Okay, so I'm looking for, so here's where the data block starts. And this is just everything. So in theory, we could basically hide it in the data packet. I don't think that's gonna work. Let's go back to TCP. Data offset. Source port is 16 bits. It's 2 bytes. Where was our breakdown here? If we grab for reserved. There. So this is 1 byte. This is a 2.5. We can't touch these. And that's 2 bytes. So that's 2, 4.5, 6.5. We can get 6.5 bytes from there. That's not nearly enough. Trying to think how I want to do this. You know what we could do? Here's what we could do. Where's the ASCII flow? Where's select? How do I select and move? Here we go. So basically, we have 2 TCP. Actually, let's do text first. TCP client. So if we have a TCP client, there we go. That's what I want. And we'll do another one where we have a TCP server. And we'll draw a box here. Okay. So basically what I think we can do is we can instrument here and here in every TCP connection. So given a TCP connection between these two illustrious boxes here, select and move you up here. Here we go. And we'll move you here, and we'll move you. So given these two, and this is really like a bad diagram because it goes both ways like I do. So giving these two connections, basically all I really want to do is send some sort of a unique identifier along with the rest of the TCP stream. What was the port? 16 bits, source IP must be 32. What was the source port? 16 bits, source IP must be 32, right? Yeah. We can't touch the source port or the destination port, both for IPv4 and IPv6. Ask me how I know this. So I have to clean, thanks Chris, now I have to clean coffee off my keyboard. You're fine. TCP timestamp option allows some tweaking. What's TCP timestamp? Let's go look at TCP timestamp. So basically, I thought this was just an option, right? Isn't this just a synchronize, reset, push function, acknowledgement field, urgent pointer? To keep a current measurement of the round trip of the networks between them. This value helps each TCP stack to set and adjust its retransmission timer. There are other benefits, but RTT... No, and also we're going to be using the... Where we're going, we're actually going to be using these TCP timestamps. But let's analyze. Okay. I was drinking coffee while listening to software engineers. That's pretty much a metaphor for my life. Okay, so we want to walk up to an existing TCP connection. And we basically want to understand its total throughput. And we want to also understand... What else do we want it to understand? I think we want to give it an ID. I think we want to give it an ID. And I suspect some network hardware and some network software is going to drop it depending on where in the packet it is. And this is why TCP encapsulation exists. So my original thought here is on the client side, there's this function in the kernel. Well, it's actually in glibc. It's called send-to. I think we haven't. Let's go look in boopkit really quick. Who remembers boopkit? I got some good networking code in here we can look at. So here, I think we have send-to. Yep. So it's the send-to function in glibc. So let's see. Here we go. Send to the Linux man page. So it's in types.h and sock.h. The system calls send, send to, and send message are used to transmit a message to another socket. This is basic socket programming. Send once the socket is in a connected state. The only difference between send and write is the presence of flags. If send-to is used on a connection mode, sockstream, blah, 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 the argument destination adder and address length are ignored. Ah, so send-to, we've already established the destination address, basically. So send and send-to are just basically two different avenues, depending on how high or how low in the stack you are. That makes sense. And if you look here, here is send-to, and it's got a sock adder and a sock len, and then here it doesn't have those fields. So send and send-to, you know what? And I almost can guarantee, I bet send-to calls send under the hood. I would be willing to guess it does. Or probably the other way around. Send calls send-to. So anyway, looking back at our diagram, where's our diagram? Here. If we have send, and we can instrument send, and we can actually add, was the boopkit written in Rust? No, boopkit is written in C. I think I wrote this one in C. Yeah, this is all written in C. Here's a link here if you want to see it. So really what I'm thinking is, where's my diagram? Bollocks. Okay. If we call send, we can effectively instrument the packet every once in a while. Welcome back, Nova, says Lucent. Thank you. It feels good to be home. I missed you all. I missed you all a bunch. So if we call send, we can instrument the packet. We can give it an ID. And on the server, the problem is we don't want to actually touch the data. This is the big problem. If we could guarantee that the client and the server were both running TCP jack or whatever we want to call it, we could just instrument everything here. However, we don't know that's the case, and if we're instrumenting connections, then You know what we could do? What if we did this? What if... Where's my text? Over here, we basically injected a tracer packet. Into an existing TCP connection. And the tracer packet would basically be like, I hate to say it, but it'd be like a tracer round if y'all are familiar with this concept. And the tracer packet, you know, would send every, like, let's say like 500 packets or something. You know, we'll say in... And this, the payload is arbitrary. We'll just call it maybe BSON data or whatever. It doesn't really matter. Some sort of encapsulated data. We don't care what. Okay. And we know on the server side, and we'll give it a bad checksum. This is great. We know on the Linux server side, if we give it a packet with a bad checksum, we know if it gets a bad checksum, it'll just effectively ignore the packet. Now, there might be other consequences to this, like other networking tools might drop it in transit. I wonder if there's another way to basically send a bogus packet that we know the server will ignore, but it won't cause any problems. Like, we definitely don't want to call, like, flip the fin bit. We don't want to call a sin ACK or anything like that. What are the other flags? Push function, reset. I guess we could. I'm wondering if we, like, send a malformed packet, like if we flip the urgent bit and like the reset bit or something just very strange, if it'll just drop the packet. And the reason I say this is because then we can basically, if the server is instrumented, we can grab the packet off the wire and unpack the payload and do stuff with it. If not, we just want Linux just to drop it. And we want that to work on pretty much every machine. Just uninvasive, just herpy-derpy, bad packet. Maybe we'll like log a line and move on. No big deal. And if people are listening for it, if they have, you know, Wireshark deployed or networking probing set up, it'll maybe help with that, but help like surface that. The last thing we want is to send a valid transmission packet. Where the data is not what the server is expecting. Because remember, we're injecting a packet in the middle of an existing TCP stream. So the last thing we want is to send bogus data to the server. So we definitely want to make sure it's something that will be dropped even if it's not instrumented. What about sin ACK? Let's write these down. Let's write these down. Let's come up with an approach. Okay, so we want to, how do we want to type this? The a TCP instrumentation tool, which will inject a trace packet in an already established TCP connection. We'll say not vectors. What do we want to call our strategies? Okay, so the strategy 1 we want to try is send a SYN-ACK packet to the server and ensure the server ignores the payload and the payload is not passed to the user space. We'll say to user space. Okay, that's strategy 1. How will the tracer work with TCP sequence? That's a good question. About sequence numbers and ACK numbers. I came in halfway. Are you building something like Paratrace? Benson's here. Hey, Benson, how's it going? Benson, I'm trying to build a TCP tracer similar to Paratrace, yes. And our good friends just reminded me that we actually have to keep count of our packets. Except for I thought Paratrace used ICMP like trace route. Maybe I'm mistaken, Benson? So this is why I want to use. I wonder if it's worth looking at Paratrace and Wireshark. I think Paratrace uses ICMP. I don't think it uses TCP. I don't think it does. Somebody go look and see. It's definitely sending TCP packets because it's for tracing TCP connections. It does. You have a link we can look at, Benson? I would love to see this. man.cx/Paratrace. Let's go look. Let's go look. Paratrace. Parasitic trace route via established TCP flows and IPID hop count. This sounds very similar to like what I'm thinking. How did you know? Traces the path between client and server, much less trace paths, but with a major twist. Rather than iterate the TLS, UDP, ICMP, or even TCP SYN packets, Paratrace attaches itself to an existing stateful firewall-approved TCP flow. This sounds quite literally like what I'm thinking. Stateless releasing as many TCP keep alive messages as the software estimates the remote host is hop distant. The results in ICMP time exceed replies are analyzed with their original hop count tattooed in the IPID field of the ICMP packet. So it reports back over ICMP. That's how traceroute works as well. So many helpful routers through this process. Paratrace can trace a route without modulating a single byte of a TCP layer 4 and thus delivers fully valid, redundant segments at layer 4. Segments generated by another process entirely. Man, somebody stole my idea. Except for they're able to do it without mutating a TCP IPv4 packet. Parasitic trace. I hate when that happens. I mean, this is Linux though, right? This is just what happens in Linux. Nice idea, says Rage Cuddle. You could try injecting packets in the challenging ACK side channel, keeping your channel ACKs misaligned with the receive window. Well, so this is kind of what I was thinking, was injecting into the SYN ACK. If you flip this bit and this bit, I'm pretty sure the payload is dropped. And depending on which version of the kernel you're using, the kernel might do different things. Let's see. Linux NFQ, net filter queue, TCP trace routes, man in the middle, TCP packets. So this is fascinating. So I was considering actually instrumenting the actual client. It looks like there's some pre-existing work where you can actually do proper man-in-the-middle attacks, where the sequence number and the ACK number will obviously get fuckered up in the process. But I was basically just trying to hijack an existing connection and just send a payload, probably with a unique ID, and probably some latency information. Was about as fancy as I was gonna get. And then just send that, you know, every 30 seconds or something across the wire. And I think you can do it just using eBPF. I think we could just instrument the send function in the kernel and the receive function in the kernel. And if it's got a certain header in the payload and meets another set of conditions in the packet, we could just pop the packet off and ignore it, basically. That was my thought. It may not be clear what you're doing, so that's because I'm not clear what I'm doing. The problem I'm here, I will start with the problem. We should approach this like real engineers. Oh. So the problem I want to solve is measuring, basically I want to start to measure TCP connections and trace them without any of the HTTP or higher order protocol stuff. I don't want to touch HTTP. I just want good old-fashioned TCP or below, or Ethernet or below. Another method you could use for TCP would be just MSS down its setup, and then you use the space you had made to carry tail data. Yeah, we could basically offset the entire data block when we set up. But again, like the whole point here is that I want to be able to walk up to a pre-established TCP connection and not have to change a thing. Dan Kamitsky is legend. It's kind of cool that he stole your idea. That's awesome. Well, we can figure it out. We can figure out a good way to make it happen. So I like what he did about reporting back over ICMP. I think that's pretty clever. This is kind of how the stun stuff works as well, is you just kind of use a different protocol to do your dirty work because you're lazy. So what do you use these metrics for in the connection? Which metrics? Rip Dan. Yeah, Rip Dan. Which metrics? Says Fafinaboot. So really what I want to be able to determine is, you know, if there is some sort of connection pooling or TCP proxying, I want to know where it starts and stops and where it's getting cut off. I also want to know latency. That's really the one I care most about. Not necessarily on the wire latency, but I want to know latency in between packets. I also want to know, this is going to sound strange, I also want to send throughput to the server. The total throughput. So basically just do like a length on the payload and just keep tally in memory, and then every, you know, 30 seconds or 10 seconds, some sampling cycle, report that. There's a Rust tool that does this. It's like a bandwidth throughput tracer. Yeah, I don't think it's going to count number of hops. Well, then this is where we get into like the I'm tinkering with ideas at this point, because we might be able to see proper hops using like the traceroute ICMP tactic, but I don't really care about hops necessarily as much as I just care about general like client to server latency. I think what I really care about is TCP reverse proxying. That's the exciting one. I want to know where some fucking dirty proxy in my stack somewhere basically tries to send data from one address to another. Not a NAT, a fucking reverse proxy. That's what I want to know about. And if it's a reverse proxy, depending on our strategy of how we instrument a TCP packet, if we even build this thing, there's a good chance that if we end up trying to sneak stuff into this packet somewhere, that reverse proxy is going to drop it. You'll see hops for IP routes, but with TTL, but I7 proxies are much more complicated to detect. Yes. Or L7 proxies. Yes, yes, yes. Can we send UDP packets over a TCP connection? I guess it doesn't matter at that point. I don't know. I'd probably prove some behaviors by trying to inject fragments and so on and see how they impact the windows. But you'll need to derive some stuff about Q disciplines to figure out precise details. The Q stuff I have down. The Qs in the Linux networking stack are very familiar to me. I'm not worried about those. Kitty Cuddles makes typing slow. Client server rather than internal metrics for your service stack. Yeah, this is all about distributed tracing at this point. Not proper distributed tracing, like a new thing or an old thing, I guess, depending on how you're looking at it. Oh, I'm thinking. Let's go look at this again. I want to find the source code for this. That says email. Doxpara.com. Yeah, so this is what bandwidth calculation presently doesn't take into the time necessarily to actually send a given packet. This is the data, what this person is referring to right here. This is the type of data I want to see. I want to know how much bandwidth or throughput, which I understand these shouldn't be used interchangeably, but I use them interchangeably because it's my fucking show. I want to know how much is going per TCP connection, and more importantly, I want to see a real-time latency time series plot. Sadly, I think Dan's website is gone now. I'm just gonna Google this. I don't think this is the actual... I want to see the source code, basically. commands paratrace. I want to see the code. Where's my code? This is service trace route. TCP info sock option gives you the kernel's view of those metrics. Yeah. Like, I don't even think paratrace... Is it here? Yeah. Where would I even find paratrace? That's the question. Somebody give me... Is this thing even around anymore? The package it was in was called Paketo Kairutsu. You're saying this? Isn't that a name? Does anyone have a copy of the sources? But it's the most recent version. Yeah, I have a copy. Here's an archive.org. Not finding it. Looks like I found a tarball here. Let's go to downloads. And we'll save it. Here we go. Okay, so let's get this. Someone should really archive it on GitHub. If only we knew somebody who worked at GitHub and could do this. Looks like this goes back to... I guess we'll have to go and just do this whole thing. Why don't I just do this? We'll do... That was 2.0 that we just got, right? Yeah, so let's do... But what exactly are we looking for? I mean, at this point, we're just kind of just going a little bit crazy. New repository. So let's go to here. Ah, not Google Lens. Oh my god, I'm all over the place. Marathon, not a sprint. Here we go. So here's his old website. Dan Kaminsky. So here's dankaminsky.com. So it looks like it's here. Big Indian support. Okay, so this is keto. Oh, here we go. Cancel. Dan Minsky. See you around 5. So let's grab this. So all right, so let's find this and we'll go to downloads. We'll move Paketo there. Okay. tar xzf, extract the files. Paketo. Not gzip format. It looks like a tar.gzip. Am I... Let's go with this. Some other compression algorithm. Yeah, I think it's just, I can do this. It's fine. So basically we'll grab all of these. We will extract to Novix source. Keto. Extract. And close. And let's go see. Oh, we're getting a raid from Purple Elf. Thank you for the raid, Purple Elf. How was your stream? Welcome to the show. Welcome in, everybody. So this was 2.00 pre-5. There we go. Fair trace. Cool, now we can look at the code at least. Should I just go like solve some of his to-dos for? Should I just go fix some of these? And just be like, thanks for your work. Proper demonstration of Gorilla multicast. The pizza protocol? That would be truly legendary. Nat to nat for the Black Ops talk. Much, much more, smiley face. Source port weaving. Interesting. Visualization for ScanRand. See, this is the stuff I talk about at work all the day. I wish I had more time. I would do so much cool shit if I had the time for it. This is the stuff I daydream about. Let's go look at the source code. So libpaketo.c, packet scan, prox.c, scanran, tin can, stamp, IPQ64.h. Let's go look. See, I don't know how I feel about these like donuts.c. Is it do nut? I don't even know. Donut, anonymous spoofer for experimental bandwidth. It's the name of a command line tool. I hate it less now. So the one we were looking at was called Paratrace. Here it is. Paratrace 2.c. Include libpiketo. Main. Options, margs. Already building a TCP packet. Wow. ICMP. Safer for all sorts of reasons. He creates a new thread. Chris, you already do so much cool shit. I love how short this is. Yeah. Estimate hop count. I like how it's called spew. Spew, spew, spew. Packet sniff, get next. Well, I mean, it's all in libpiketo, which is, I suspect this thing is. Let's go look at the header. Yeah, that's not that big. Where did it go? Let's go look at the implementation. So we have a function, parse layers, icomp. I call this icomp. Sometimes people make fun of me for it. I don't care. Spoof raw. What is spoof raw? Let's see. So we pass in a link. What is a link struct? Is there a link in here? HI? No. So anyway, where's spoof raw? Okay, so link, an int layer. So the layer 3 cars packet. That's a raw packet. That's gonna be a raw Kaplan and packet. This looks like wire, or not Wireshark. What's the name of the library? PCAP, libpcap. This right here is very probably libpcap. What are his includes? Oh, he does the weird thing where you import everything through the header, I bet. Let's go look at the libpiketo. There's got to be a bunch of includes here. There they are. There it is. Libpcap. So, okay, so he's using pcap to come straight off the fucking wire. You know what? Y'all want to see something pretty funny? I don't know who this Dan, whoever Dan, whatever his name is. I just stole all of his code. Kaminsky. I don't know who this Dan Kaminsky character is, but what I really like about him is how we both used... let me see. This is just really interesting. This is just like psychologically very interesting. Where is my DPI? I think it's DPI.c. So yeah, so here I use pcap, and I used the character X for all of my like arbitrary packet capture stuff. So I called it like xcap ring buffer. And I basically created this, like if you just grep for xcap, for x capture, I just used that as my way to basically say, this is my like arbitrary packet capture work that I was doing. I just think it's very fascinating that he is also using the character X here for the same thing. Just interesting that our brain both just wanted to just call this thing X. I don't know why, just find that very fascinating. But he did it here as well. X frame. Yeah, he just called his frame X. That's delightful. It just, I don't know, just little things like that in the world just make me happy. Anyway, so he does sniff get next. Okay, so he's basically... packet sniffing using libpcap. And then he spoofs a packet. So if layer 2 No device found. So he uses libnet, open link interface, get time of day, link, return I, libnet, open link interface, write link layer, link def, packet in length. So where does the packet come? You pass it in. Okay, so if he spoofs layer 2, basically all he does is he just uses this link layer writer, which I'm assuming is built on like some virtualization library. Probably the same stuff that the ton and tap packet stuff is built on. So that was link layer. So is there IPQ, Homer, Donut, config, base, Acmon? What is this lib IPQ? No. It's an interprocess queue. That's probably how he's communicating for IPC. Yeah, IPQ. Where's his link layer library? No, there's nothing else. It's in here somewhere. LC2, maybe? No. Packet scan, packet serve. I don't know. Anyway, let's go back into paratrace. 2.c means X marks the spot. I mean, honestly, that's probably what I thought. Okay. So where was if layer 2? Oh, we were looking in lib Paketo. What does Paketo even mean? Does anybody want to go look that up for us? Layer 2 libnet. Let's go see what he includes in libpaketo.h. So hash table, packet scan, base 64, standard IO, config, encrypt, libnet. Libnet is where it's coming from. Packet construction and injection. IP guard, ARPing, Nemesis. Ooh. TCP trace route. Who's heard of libnet before? This is where all of his packet injection's coming from. There it is. It's in the Arch user repos. DHCP, DNS, build, inet, error, link PF, link linux.c, erand, port list, pp block. Portable framework and low-level network packet writing and handling. With libpcap, you can write some really cool stuff. Libnet includes a packet creation at the IP layer and the link layer as well, and a host of supplementary and complementary functionality. Libnet is very handy with the right network tools. Some projects available are the man page, building on GitHub, building with Docker. So libnet looks like we can do packet injection, which is fascinating because I just wrote this from scratch. Last time I did packet injection like this, I just wrote it just using glibc and C structs and just spoofed all the structs manually. Fascinating that there's a whole dedicated library for this, and it supports. It looks like, look at all these protocols it supports. There's a fuck ton of stuff I could do here. Okay, so this, hey Arjun, how's it going? This is exciting. I didn't realize libnet was a thing. It's got a good name. Whoever heard of libnet before? How have we not heard of libnet is a better question. It just feels like it's like the 90s called and they want their C library back. Paketo is Japanese for packet. Kiroto in Japan, a conglomeration for business linked together with cross-shareholdings. I've heard of libnet, says Benson. Benson, grown-ups are talking here, Benson. Heard about it in the 90s. No, you're cool. Thank you for the follow. Yeah. So, packet business. Is there libnet rust bindings? Pnet. libpnet provides a cross for low-level networking in Rust. The packet modules. Look, there's data link, network, and transport. Thank you for the follow. So look, we have the layer 2, Ethernet packets, find the network interface with the provided name, create a new channel dealing with packets, TX build and send, packet len, mute new packet, mutable Ethernet packet new unwrap, new packet clone, switch the source into destination. Fast. So there's this, here's libpnet. There are 4 key components: packet, pnet macros, transport, and data link. New transport layer protocols. Let's see. Write it in scripting language, write it using C. Higher level abstractions, memory, and thread safety alongside the performance of C. Almost, not quite the performance of the C. Okay. So we have this we could use. So let's go back, now that we've done some research. I know I kind of got off on a tangent here. Let's go back to our TCP pack. Now that we know we have some options available to us. Let's so we want to do TCP tracing. Okay, I think I know what I want to do. Here's what I want to do. Let's talk through this, all right? Everybody get comfy. We're going to talk for a bit. We're just going to chit chat. I want to see coffees. Coffees in the air, everyone. Hold your coffee up high. We're going to talk. In fact, we're going to the talking camera. Okay, so here's what we got. We want to basically build the following. We want to basically recreate paratrace in Rust. However, we're going to use the OpenTelemetry OTel trace context standard, and we're going to encapsulate TCP packets with trace context data, such that if a request is coming into the kernel with an HTTP ID, trace ID, we can carry that through TCP as well. Is there a TCP trace standard? I know there's trace context from in open tracing. Let's see. Let's go see. In straight TCP, we want to have all requests traced throughout our system from the edge are encrypted. We cannot attach trace data to each request. Of course. Proposal. When was this written? 2020. Trace header support. So here's the trace context. HTTP headers. This is all HTTP. We don't care about HTTP. On IPv6, you can shove it in custom options. Yeah, but we don't. So we just want. This is why I wanted to do it to TCP. TCP is uniform everywhere. TCP is never going to go away. We can run TCP over IPv4 or IPv6. That doesn't matter. Enough space inside the MTU. Between the headers. So this is all HTTP tracing. Which, like, don't get me wrong. This is good. I want to bring this to the TCP level, basically. And I think the way to do it... I wonder how big Quick will be able to replace TCP. I mean, HTTP 2 is already here. Over Quick. It's like a fucking DiGiorno pizza, baby. It's already ready already. So, I think there was a proposal to add this to TCP, but I don't think it went far. I agree. Session state. Oh, Metal and Coffee is rating. Metal and Coffee rate. What's up, Metal and Coffee? How was your show? Welcome into the show, everyone. Welcome to the Nova Show. I'm your host, Chris Nova. Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. Welcome to the show. Welcome in. Tell us about yourself. How was your raid? I did some rock climbing. I thought about metal, and I drank a lot of coffee while I was rock climbing. It was fucking awesome. I love you all. Welcome to the show. Shout out to Metal and Coffee. Great shout out. There are some arcane differences between TCP and TCP6. I wonder how much of it affects this. I don't think that much of it's going to affect this, honestly. I don't think so. Because I avoid the hearsay of TCP6. No, you're all good. So that's my idea. That's where I think we go with this. After looking through the state of the art and figuring this out, I think... Here, we can close this. This is just an archive. After looking through the state of the art here, I think we want to be able to instrument TCP. Now the question is, do we go with libnet and just do it in... I kind of just want to write it in C. I feel like nobody will use it if I write it in C, though. What do y'all think? Do we start to prototype this out in C or in Rust? I think you do it in Rust because Rust makes you happy. Well, also, if I do it in Rust, I can probably, like, get away with working on this at work, too. C has been dying since the 90s. You shut your mouth when you were talking to me. C is my favorite fucking language. Just for that, I'm writing this in C, and there's nothing you can do about it. Well, because if I write it in C, we can actually just vendor it directly in Rust. Low level C is more secure to work properly. Yeah, honestly, if I write it in C, there's just gonna be a ton of CVEs with it. The words of a true C programmer right there, folks. I don't want to have to deal with memory safety in C. Although, that's probably already done. I'm writing it in C. Fuck you guys. I don't give a fuck. Metal and Coffee just raided. It's fucking Friday. I'm going all out. We're gonna delete all of this Rust. We're going all in on this. We're gonna write this in C. C party LOL. It's gonna take forever if we write it in C because of the command line options. I'm writing it in C. You guys can't stop me. Right. Decision is made. Deleting our cargo, deleting our build. We'll keep source, we'll delete proto. Delete. Make file. Close you. In fact, you know what I'm gonna do? We're gonna go into TCP inst. We're gonna remove this. And we're gonna close this really quick. And we're gonna echo 0 into the license. We're gonna move you to Apache 2. Let's find an Apache 2 somewhere. I think there's one here. I think there's one in my GitHub, yeah. There we go. Okay, so copy license to source. TCP. We need a better name now than TCP inst. We need a better name than TCP inst. It's basically gonna be a TCP tracer. A tracer out implementation using TCP pack. And also, let's see. I don't want to call it T-trace. Let's call it... Let's call it... We'll come up with a name later. Here we go. So here in the make file, executable. We will call you. This is my tracer for you. I wonder if there's a synonym for trace. I almost wanted to call it ptrace, and I was like, why does that sound so familiar? Is there a packet tracer out there? And I was just like, no, it's that stands for process trace. Pack trace, Pac-Man. Pack map. Call it trace for stuff tracer. We'll just call it TCP trace. Plain fucking Jane, folks. License an empty repo. And then TCP inst, we'll get rid of it. And then it's going to be github.com/chrisnova/TCP inst. And we're going to settings, rename to TCP trace. And I don't think there's anything out there called TCP trace today. Oh, god damn it. There's tcptrace.org. What is this now? This has got to be a completely unrelated. God, the networking programming is so obnoxious. You can just do so much goofy shit with the network. It's just so fucking nebulous. It's like the network reminds me of the human condition. It's just messy as fuck. There's no rhyme or reason to it. I mean, none of this stuff is loading. Here we go. A TCP connection analysis tool. Show zero lengths, show segments. PCP trace. How about live trace? Did you trace a live connection? We could call it jack trace, because we're basically hijacking TCP connections. We can call it, it's like dynamic. So in eBPF, we call this dynamic instrumentation. We could basically call it, you want to call it jack trace? What about tap, like wiretap? Tap trace? Peep trace? Boop trace? T trace? Peep trace? Dynamic trace route is much more businessy. I know. I don't need it to be businessy. I just need it to just not already have a name. D trace. TCP tap. I like TCP tap. Was that going to get confusing with tap interfaces? Chris Nova trace? TCP tap I think exists. I think TCP tap definitely exists because of tap interfaces. Maybe not. I think TCP tap is our winner. Nope. A chat operating and go. There's nothing for TCP tab. Dang, it does. Nova trace? It's between a client and server and shows the data that passes through. Very similar to what we're building, but not what I'm thinking. Wayne is the best name. Reconnaissance using unused shenanigans tracer. Naming things is really the only reason people come to my Twitch channel. So we called it Jack Trace. I mean, it's porn. Jack Trace is a porn name. Sketch Trace. Do we want to go with Jack Trace? Because we're hijacking TCP connections? Sketchy Trace is funny. Alright, so it's either TCP tap or Jack Trace. I'll let you guys pick between those two. It's either... Jack Trace is good. Pack trans pack. Where you make it something TCP. How about TCP trans? I don't know how to make polls. I think you just do /poll Benson. TCP. TCP Jacktrap? Do we want to do... Oh, let's use X because of the nod to the fact that we both used X in our PCAP implementation. So like we could do like X trace, X tap, X trap, trace X. I think we can only... I know, I'm just thinking out loud at this point. I'll never remember how to spell Jack. X-trace. X-pack. TCP Jack? I think we should just do TCP Jack. Do you want me to make a poll of these options? Yeah, or just somebody just tell me, somebody just make the decision for me. I think they all suck. I think they're all pretty horrible. Call it TCP Jack and move on. Is there one called Trace Cuddle? TCP cuddle. TCP jack. TCP trap. 3CP. Jacks into a TCP connection. It's good. Just use it. TCP jack. Okay. Okay, hold on. But hear me out, though. TCP gel. Some people might get confused. I vote TCP gel. TCP gel +1. TCP gel and only a few will get it. Cool. Done and done. The settings. TCP gel. Tap TCP. We're going with TCP jack. You guys can't change my mind. Alright, cool. We're done. Decision's made. Sometimes you just gotta name it the right one so you know which one's the wrong one. Tarzan. Alright, TCP jack. There we go. Make. Nothing to do. Alright, cool. So, let's write down what we want this thing to do. Open TCP jack. How long do I need to get a job in cybersecurity? 6 months, 1 year? I don't know. I'm like the worst person to ask these questions to. I'm just a shitty software engineer. There's nothing to see here. Ask somebody in the chat. They're better at these questions than I am. Okay. So. We'll keep our TCP packet here. Depends on you. Okay. So what we want to do is we want to list existing TCP connections we can hijack. 2, we want to instrument an existing TCP connection. 3, family's here. Y'all want to see the family? We haven't seen the family in forever. It's family time. Here, come tell. We're streaming. Arjun's here and everything. Okay. The chat's right there.
Oh yes, puppy. Gotta have puppy sparkle. I have Hi Arjan and Mr. Wizard and Benson and Mador. I don't know if that's how it's pronounced, but that's how I'm pronouncing it. Got your bedhead. Going around. I mean, it's only 4:30. I was gonna go defrost some stuff, so that's ready for dinner time.
Okay, I'm getting pretty tired anyway. I'll wrap up this readme and then I'll come upstairs and I'll start cooking, okay? Love you, sweetie. What are you defrosting? We have a bunch of graham already in the fridge, folks. Okay, then grab 2 graham and 50. Okay. Okay, so let's see what we have here. So list existing TCP connections. We can hijack, instrument an existing TCP connection. What else do we want to do? I think that's probably good. And so if we instrument an existing TCP connection, what we can do is we can basically trace all the hops outbound over TCP, and we can report back over ICMP, and then we'll just echo it out here. We don't even need to instrument the server side. Okay, go check now. I think that's it. I think that's really all we need to do. I'm gonna write this in C. I'm gonna write you in C, you motherfucker. Let's see. And we want to build a static binary here. So I think what we're going to want to do is basically do this here. Where's our makefile? So compile, we will do this. And our target will be here. I think everything else here is going to look like this. User local include, libBPF, libpcap, libpthread. So I think we just want... I know this will be the only one we have to link right away, and I think it's also going to be lib... What was it called? Libnet? Nah. Probably like that. Okay. Style Google, so C flags, LD flags, lib static. Okay. There's that. And then where's my format? Here we go. We'll steal you from Boopket. And then it'll be source. Such. And then I guess we also want an include for our API. So we can use it in Rust later. Cool. And our compile, and where's compile here? GCC. Do we want to use GCC or Clang? I guess GCC since we're going to be and we called it TCP Jack? What do we call it? TCP Jack. We did. Okay. There we go. That looks good. And let's go and we'll do a new directory called source, and we'll do a new directory called include. And here in source, we will do a C file called tcpjack.c. There we go. And we'll change our license here to I think that looks good. Cool, so there's our make file. So we'll grab a nice big sexy header here in tcpjack.c. And in include, we will do a nice big fat tcpjack.h. And we'll put a header there as well. We will grab... Oh wow, my C is gonna be rusty, but I am very excited to write it again. Okay, so return 0. Where's my make file? It's got all of my DPI and here we go. So GCC, this will be source tcpjack.c. Oof. And so let's replace the pound with a double everything. Okay. And we'll do go, and let's try it again. Lib pcap, libnet. So we'll get rid of you for now. LD cannot find. Where IG blank. Where's my dash G? I don't see dash T anywhere, do y'all? Ah, wait, that's G. LD cannot, no such. GCC include user local include dash G. Why is it still, why does the linker think, where are we getting this empty? I guess from here, LD flags. Good call, Felipe codes. Okay, so, and now if we run TCP jack, it should just exit 0. And it did. Okay, great. Cool. So it's compiling. So now let's include TCP jack.h. Make sure that this works. TCP jack.h. Make file here. Goes this, and then here in our make file, we include it now. Let's. Do I need to include it there? Let's see. I think we all basically want to do there we go. Cool. So let's do a pound define in our header. So this is how I kind of always get back into C. This is what I do is I hate how it's always trying to rescan my makefile here. I always do a pound define with like a version. And it just kind of like helps me get back into the swing of things again. And it's good because it like makes sure that like you're compiling your program correctly and it gets like a bit of data. It's just a good like warm-up exercise. Okay, so we also want to now include what is it, standard io.h, and here's basically going to be a printf, and this is version. Our format will be like such, so string new line like such, and there you go. We'll say TCP jack version this. There we go. Make and TCP jack version 1.0.0. Okay, so let's take a few notes and then we'll push our code up. I'm not going to actually write any implementation today, but we've got it started for my next stream, which will be good for us. So thank you for the follow, RidgeXE. Or should we get libnet vendoring? Let's get libnet in here and then I'll go cook Q dinner. Let's do libnet. Cool. So let's where's my make file? Let's see. Now, libnet is not there. tcap.h. That looks like a Nova file. That is a Nova file. Let's go to user include and see what we, yeah, here we go. So let's see what we have. We have lib soup. There's libnet. It's here. Libnet headers. Okay. So that was in user include. And then LNet. Let's try that. Source, what was this thing called? TCP jack make. Who thinks this will work? I bet it'll work. Cannot find LNet. Yo, my team is strongly considering you moving from the Kate's Terraform provider to using Neil at work. Thanks for creating a great project. Yeah, go for it. Use at your own risk. I think there might be some better stuff out there, but fuck yeah, I'm happy you like the client. I'm all for writing things in Go if possible. Okay. So this says we actually want this WL thing here. Like this. No such file or directory. Let's go see. Maybe there's some examples in the libnet. This is libpnet. I want libnet. So let's find TCP traceroute and see what they. Oh, I just want IP guard maybe. Oof. RPing. Here we go. Bootstrap configure.ac. Where was let's see what we have here. There's a configure file. So this is capital libnet. libpcap. So it looks like he's actually pulling in his dependencies natively. Oh, and he actually has a full thing. Wow. You don't see code like this anymore. Remember we used to have to write all this stuff ourselves, you guys? And you used to just copy and paste these around? Who remembers this? Is Benson still here? I feel like Benson would remember. Pepperidge Farm remembers. So it's just got to be LNet like this. We're just going to get an AI to do the copying and pasting. Yeah, exactly. LD flags and libs. TCP. You think it would just be... One second, I'll be right back. Quick break. Okay, sorry about that. So you think it would just be... We have -I user include, and we have libnet, but it says it's not. Libnet. So it could be net headers, maybe? You know, is it actually this? Is what's going on? Because it's not compiled as a shared object. Is that why? That's why. It's not a shared object, you guys. And then if I yay, how do I get pcap? Isn't it lib pcap? I've installed it before. Is it just Wireshark? libpcap. There it is. Oh, it's already installed. Let me upgrade it. What are these LD configs, by the way? It's... What's it? Did I install some CUDA shit? Yeah. Oh, John the Ripper requires OpenMPI, so let's just try this one. Can I upgrade CUDA? Yeah, let's try this and see if we fix it this way. That's one thing I wish I had more time to get into would be the CUDA libraries for the neural networks with machine learning and artificial intelligence. If I was smart, I'd be going forward in time and not backwards in time. Instead of going back into the 90s and dealing with fucking TCP tracing, I'd be going forward and building neural networks with Python and CUDA and building CUDA kernels. Wait, I tuned out for a minute. Now we're password cracking? No. Hey, the 90s were awesome. Do you have libnet.so? Yeah, no, I don't because it's not the shared object. I just have the header, which I'll just compile directly. I'm about to get the pcap shared object, so I will do -l for that. Also, my hip flexors are fucked, you guys. libpcap not found. So we're just waiting for CUDA now at this point. Okay, so we can open up another terminal when my system unfuckers itself. Here we go. Makefile readme. Here we go. That looks good. Still downloading. Make libpcap.h isn't not found. I think it's... I think I remembered the reason I did this was to actually link shared object when I compiled bootkit for some reason. I think I needed to do some weird thing because I was like statically compiling it. Which for now, if this works, let's keep it simple, am I right? There we go. TCP Jack version 1.0.0. Okay. So that works, and we have eCap and libnet here. So let's go look at libnet implementation now. I love how I was like, I'm not gonna do any of the implementation. I'm gonna go cook dinner, and well, here we are. Smurf.c, sinfled.c. Where the fuck has this library been all my life? This is all the things I want to do. This is all the things, you guys. IEEE.c, what the fuck is this? Packet shaping IEEE 801. Oh my god, I am gonna break the internet again. You know what my favorite part of the 2020s has been, y'all? You know, like this whole world is completely fucked right now, but you know my favorite part of the 2020s? It feels like the 1990s. Fucking social media's fucked. It's gone. It is gone forever. It is fucking fucked forever. Wireshark packet sniffing though, back in style. IRC Matrix back in style. Wow. Okay, so we have arp.c. I just want TCP. Here's TCP1.c. Libnet. Build a TCP packet. Okay, let's see what TCP2.c is. Where are the trench coat, sunglasses, and underworld though? Like, I don't know how to help you write that code, even though back then I didn't do anything more interesting than Perl scripting, but I knew CUDA was, and apparently that was worth the consideration. That's right. So what does this do? So libnet build, this is raw TCP. This is build a TCP packet. I don't really... I mean, it's cool that you can just build it with this function, don't get me wrong, but I want to list TCP connections. What the fuck is this ping of death? Wow, this is great. IP link, IP raw. We need some vaporware music in the background. So I do have this. Here, let's mix it up. Here we go. Didn't we just have a new ping of death? I don't know, did we? TFTP? What is smurf.c? Build smurf packets? So let's see, can we do... I want to see how to basically intercept or how to add a packet to an established TCP connection with this library. Let's see, what is it? It said something in the README about this. Injection, that's the word. Using -lnet. We should have just come read this. Include libnet.h. Package config, user local include -lnet. So we could actually come and do this correctly. I won't do it today. If somebody wants to come PR this the right way, they certainly can. So how do we do packet injection? Let's go back to sample. Redirect. What's Tring TCP? I want to see what this says. T-ring. To ride on token ring. Token ring. We'll initialize the library, so libnet. Source, payload, null. While get opt. Build TCP, so we build if t equals -1. Build IPv4, so we build an IPv4. Okay. Token ring. There's libnet build token ring. Source IP. Build TCP options. Reload. Libnet write. Write it to the wire. So how do we build IPv4? Okay, so TCP 242, build TCP, source port, destination control flags. We expect the input to be in the form of IP port. We point the CP to the last dot of the IP address. Null byte. Now, does this attach to an already established TCP connection, or does this create a new one? That's my question. Bad destination IP. Name to adder. Are these commented? Let's go see. They are. Look at this. This library is the fucking tits, you guys. Take a dotted decimal string and a canonical DNS name and returns a network. What? This library is fucking amazing. Fuck libpcap. This is my new favorite C library. libpcap stonks going down. That resolve. That's name to adder. So where's write in here? And then we said inject, right? Packet to inject, advanced interface, writes packet network at the link layer. So Ethernet is useful to write a packet that has been constructed by hand by the application programmer, or more commonly to write a packet that has been returned by a call to. This function is part of the advanced interface and is only available when libnet is initialized in advanced mode. Okay. libpcap going down, libnet going up. Vincent, you didn't even know how much you loved me when you first met me. You were like, who's this person? She seems kind of cool. But now we are the best of gluten-free friends. With the probable intent of inject a series of packets in rapid succession. Much of the time the application programmer will use the iterator as it is. So what is this? This is the CQ head. Context queue. Advanced write link. So we get a new libnet T. What is libnet T? Creates the libnet environment, initializes the library, and returns a libnet context. If the injection, so basically we just do libnet. Wow. Okay. Seriously, Tits McGee, I'm sorry. PCAP is cool. Libnet is cooler. It's got better docs. It's set up better. I like it more. I'm glad I'm using libnet. This is the right thing to use. This is my new favorite C package. Okay. So. Device. Cool. So we'll start here. We'll put a big thing in here. So left off here. Basically, go start at here. We'll say we want to initialize libnet and the libnet T structure. We also need to do the plumbing and command line command for list and jack. How did I spell semantics? There we go, semantics. Okay, cool. So I will commit this and we're gonna call it a night, you guys. Git status git add, git commit, ssm, git push origin name. This was fun. Yeah, thank you for sticking around, everyone. We're gonna raid a buddy of mine who's gonna be very excited for the raid. Who here knows who underscore is? Who here has seen underscore before? He's one of my favorite people in the world. Yep, this is him here. So we're gonna raid old Zunder Bear here. Zunder. And I expect when we get there and we raid Zunder, I want to see all the emojis. So make sure you're dropping all the emojis in. And I'm really gonna try to start streaming more, you guys. Before work, after work, I'm gonna be here on Twitch. And maybe we'll finish TCP Jack as kind of a whatever thing, and we'll get back into it. I also want to open source this project I've been building at GitHub at some point. So hopefully we can do more stream. Thanks for sticking around. I love you all. I'll see you next time. I'm Chris Nova. Thanks for watching the Nova Show. I'll see you all next time.
Jesus Christ.
And pugs.
And pugs named for